So here we go with questions 33 to the end. So question 33 says for a p sublevel, the number of values of m. So if you look over here at any of these p sublevels, how many values of m are there? -1, 0, and 1. So there would be 3 values of m. So the answer is A. Okay, for a p sublevel, the L value is, well, there's the L values, and p sublevel L equals 1, so that would be B. The electron configuration of titanium ends in. All right, you look at titanium on a periodic table, it has, it's right here, has 22 electrons. So if we're going to write the electron configurations for 22 electrons, we would go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. So it ends in D2. So is D2 a choice? Looks like no, it's not. So the answer would be none of those. E. Another way to know that, titanium sitting right here, that's the second column in the D sublevel block. Remember, the D sublevel block is all of this area right here, 10 columns wide, the short columns. And titanium is the second one, so it has to be D2. Vanadium would end in D3. Chromium would end in D4, although there's an exception there, of course, to the filling order. Remember, I told you to know D4 and D9 were likely exceptions. D5 for manganese, D6 for iron, and so on. So that's another way to know the answer to that question about the titanium. Okay, which would be most likely to obey the filling order rule? Now I'll go back over here. If you look at the elements in question, we had silver. Silver is sitting right here, so that's in right there. So it's in the D block. Lanthanum is down here at the beginning of the F block. Copper is over here in the D block. Gold is in the D block, and bismuth is sitting out here in the P block. So which one's most likely to obey? It'd be the one that's not in the D or F block, because the exceptions to filling order, if there is one, they occur in those two blocks. So the answer would be E, bismuth. Lowest energy light would be the longest wavelength light. So light with waves like that or like this, which one's the lowest energy is the longest wavelength. So that would be red. And the shortest, well, the highest energy, if I ask you that, would be violet. Okay, this is just a couple of names that were on the practice test. The electrons were discovered by a guy named Thomson, and I showed you a little video about a beam of electrons being bent by a magnet. And then Heisenberg is famous for his uncertainty principle that says if you see an electron, you change where it's going, which made necessary the work of Schrodinger to treat electrons as waves. All right, number 40, the neutrons in uranium-238. If you look at uranium on a periodic table, it will have a U, and there will be a 92 and a 238. So you need to subtract to find the neutrons, so it would be 146. Remember that the 238 up here is the protons and the neutrons, so P and N, and this is just the protons. So you subtract them to get the neutrons. Okay, 4 quadruple dumbbells and 3 dumbbells and double donuts, which really is 7 different orbitals. So if you look over here, you got F sublevel 1, 2, 3, 4, 5, and you can't see them over here, but 6, 7. I can move this periodic table the rest of the way off the screen here. Okay, so 7 orbitals. So that's an F sublevel. So number 41 would be A. 42, inversely proportional to the energy of a photon. We have this little equation, E is equal to C is equal to h times frequency. So E equals h nu. We also know that C is equal to lambda nu. So we could say that nu is equal to C over lambda. So the bottom line is we could take this equation, E equals h nu, and change it to E equals h times C over lambda. Didn't write that very well, so I'm trying to figure out how to make that better. There we go. Okay, so E is equal to h times C over lambda. So if this number gets bigger, that number is going to get smaller since h and C are both constants. So inversely proportional to the energy of the wavelength of the photon would be the wavelength of the photon. Okay, an energy which is directly proportional to frequency, that'd be a photon. That's D. So the photons have energy, and energy is directly proportional to frequency. As this number gets bigger, this number gets bigger. Used to determine that phosphorus has 3 unpaired electrons, that's Hund's rule, that's E. Electrons have to go into orbitals one at a time, and can be expressed as joule second squared per kilogram meter would be wavelength. Let me show you what that is. So you got joule second squared per kilogram meter. You know that since we're looking at kilograms, that's the unit of mass. So let's find an empty spot to write here. I'll just write it down here, I guess. So we know that wavelength I'm not great with this pen. All right, here we go. Take that out. We know that wavelength is equal to h divided by mass times velocity. We know that h, the units of h, are joules per hertz, which I'm going to change to joule seconds. Since a hertz is a 1 over second, so hz equals 1 over s. If I have joules per 1 over s, then I multiply by the reciprocal and I have joule seconds. And that's over mass, which is kilogram, and velocity, which is meters per second. So if I divide that by that, I'd have joules times seconds squared over kilogram meters. So that would give us joule second squared per kilogram meter. So that'd be wavelength. So the answer is C. Okay, now down here, the highest energy light listed, remember it's Roy G. Biv. Violet's the highest energy, red's the lowest energy, so blue is closest to violet, so the answer there is D. The longest wavelength then would be yellow. That's the other one. We know that atoms can't have any more than 3 quantum numbers in common. And I've gone through that earlier in this video, so I won't go it again. The name for that is the Pauli exclusion principle. Okay, what is the increases as the wavelength decreases? Go back up here to this equation. Right here, as that number gets smaller, what happens to the frequency? It gets bigger. So as wavelength gets smaller, frequency gets bigger, because C is a constant. So the answer is frequency, but frequency is not there. However, what is frequency measured in? Cycles per second. And the result of electrons leaving the ground state and moving to the higher energy level is the absorption spectrum. So what I'm saying is, when this little electron, the electron here, gets excited and moved up there, you saw him move right then. When he comes back down, he gives off light. The giving off of light is called the emission spectrum. Absorbing light is called the absorption spectrum. So that would be choice B. So number 50 is B. All right, that's it. So I'll post that one, and now all the videos are posted. Hopefully next week we'll do good on the retakes.